Okay, so the first proportionality theorem that we're going to talk about and vocabulary word that you need to know is mid-segments in a triangle. So mid-segments are when two midpoints are connected by a line. So for example, in this picture, B and D are midpoints. We know that because of the tick marks on either side of them, and it's connected by a line, so therefore it's a mid-segment. And your fun facts about the mid-segments is, 1, mid-segments are parallel to the base, hence the little arrows. And 2, mid-segments are half the length of the side that they're parallel to. Or you could think of it as the bottom is double the mid-segment. Either way that works with your brain, you can think about it that way. So, for example, on number 1, if we know that AB is a mid-segment, we can write an equation to solve for x and say that 34 is equal to 2 times the value of the mid-segment. And so then we'll just solve for x. So we'll distribute and get 34 equals 6x minus 2. So 36 equals 6x and x equals 6. Also, I got a question earlier of, is that the same thing as just saying like 1/2 of the base is equal to the mid-segment? And the answer is yes. So either way that works for your brain to think about it, you can set it up like that. All right, next up is the angle bisector theorem. Instead of reading all that to you, I'm just going to talk to you about it. So we know that angle bisectors, oopsies, cancel. We know that angle bisectors cut angles in half. So this angle at the top is being cut into 2 equal pieces. And when it does that, it divides the triangle proportionally too. So that A over C is proportional to B over D. So that's kind of a cool thing too. So, for example, on number 1, we would say that 14 over x is proportional to 21 over 9. And then we'll just solve for x, so we'll cross multiply and get 21x equals 14 times 9. What'd you say? Oh, 126. And then divide by 21 on both sides. What'd you get? To get that x is 6. Okay, so I'll let you guys try number 2, and then we'll check it in a second. Number 2 is a little bit harder, but I'm going to let you think about it with your group. See if you can have some ideas. Okay, so I think the hardest part about number 2 is, what do you do with the length on the right of the bottom of the triangle? Okay, so if the whole bottom of the triangle or the whole right side of the triangle is 28 and you have one piece that's y, we want to write an expression for this piece. So if all of this is 28 and this is y, what expression belongs here? 28 minus y. Yeah, 28 minus y. So we'll use that in our proportion. So we can say 20 over y equals 15 over 28 minus y. And then we can cross multiply. We get 15y equals 20 times 28 minus y. So I got 15y equals 560 minus 20y. Add 20y to both sides. 35y equals 560. So y is 16. All right, questions so far? Okay, you guys okay to go to the back side? I think we got 2 more theorems on the back. Okay, so the next one is called the parallel line proportionality theorem. This one can be independent of triangles. What it says is if you have at least 2 parallel lines and at least 2 transversals, so the transversals here are the ones going up and down, the transversals end up getting cut proportionally. So for example, A over C is proportional to B over D. Or that'd be the same thing as saying A over B is proportional to C over D. So it doesn't matter which way you set it up because either way, when you cross multiply, you get AD equals BC. So for example, in number 1, we can say that A over 20 equals 9 over 15. So cross multiply, we get 180 equals 15a. So then a equals 12. And I'll let you guys work with your group to try number 2. Okay, go ahead and at least share with your group in number 2 how you're setting up your proportions to solve for x and y. Yeah. Yes.
It literally gives you like something. Same here. You gotta do the exact same thing. Is it x? It's x.
All right, so for your proportions, you need 2 separate proportions because you're solving for 2 variables. So for your x, I like to just go top over bottom equals top over bottom. So kind of view the picture like it's already set up in a proportion. So that's why I did the 2640 over 1320 equals x over 2380 to solve for x. And when you solve for x, you get like 4,760. Yep. And then for y, I did the same thing, like top over bottom equals top over bottom. So when you solve for y, you get 3,570. Awesome. Okay, questions on that one? That one has a lot more in the picture to deal with, for sure. All right, so last one. The last one's called the side splitter theorem. To me, it really just seems the same as what we just did, just in a triangle now. Because essentially, what's happening is we've got a line that was drawn in the triangle that's parallel to the base of the triangle. And then the sides of our triangle are like our transversals that are cutting it, that are being cut into proportional pieces. So what the side splitter theorem says is that 4 over z plus 2 would be proportional to 3 over z. So same thing, like top over bottom on the left equals top over bottom on the right. Question? Yeah.
Are all of these going on our proof sheet?
Oh, we don't do proofs with these. Yeah.
Oh.
Yeah, these are just for solving. Yeah, the proofs we did last class are the only proofs for this unit. Yeah. All right, so cross multiply and we get 3z plus 6 equals 4z. Subtract 3z from both sides and we get that z is 6.